Okay, to use this FFT function, I'm going to look at the Y smooth of acceleration. So if I turn off everything but acceleration, and then the 2D sliders acceleration control, I'll turn off the raw and leave just the Y smooth on. Increase the amplitude. So if I bring it down a little bit, now if the little arrow keys here, so there's a control here called FFT. Switch on the fly, change it to Y smooth, and on the panel up here you'll see that it's already picked out a signal that's around 0.7, 0.8 hertz. So that's that's the frequency of oscillation here approximately. So we can hold down Control on the left and left mouse click, let that go, hold down the Alt key on the left and left click again. You're setting it to the minimum maximum frequency that you want to detect, and then no keys, just left mouse button and set the amplitude. This will depend on how much data you've got in view at the minute. So I think those parameters should still be there. They're still set. It's just because I waved over here. So now those parameters are set. If we go to the Behaviour Builder and we say if, and then bring up the FFT control, the values that were set just in this control panel here are now in here, but we still need to tell it that it's on the Y smooth channel. You then click include, and it puts the parameters that were there into this control here. We close the bracket because that's what we want to detect. Next step, mark events, evaluate, and then we can say that we want to search this. In fact, if I go to FFT and turn off on the fly again, we can say we want to look at this over a larger period of time. In fact, if we go to the end where it stops, like that, and we say in the Behaviour Builder, we say look over this range of data here, and we say go. It's quite a mathematically intensive process, so it's slower than normal. You see there that it's detected it. There is still some more oscillations going on there, and it's also a hangover of partly because what we call the window width. You're getting like it's still detecting it here. It's not perfect, but there will be gaps in the signal. So what you can do here is the gaps here are just one or two. So there's like 2 or 3 data points missing. So we can fill those gaps in with the merge function. So if I highlight this data and go to marked events, if we just put 10 here, well, let's put 100 just to make sure some of these gaps might be slightly larger than a few. And you can say yes or no here. Global would actually merge events in other splits, but we've got all the data loaded here. So we can say no, that we just want to do it locally on this data, or the entire or what's between the white lines. So if I say no, it'll merge what's between the white lines. So you can see that it has achieved that. Okay, that's it. So using fast Fourier transform to detect signals of in a specific frequency range. Just bear in mind this hangover here. But you may be able to, if I quickly clear these down, Behaviour Builder, if FFT, we can drop that down. Let's say if we put that to 500, maybe drop that down to 15 on there. You say include, close bracket, next step, marked events, evaluate, and then if we just do it again by technically go over this range here, say set and go. Yeah, it's picked off nicely. It's because of the the window width that was set in this panel. Just bear in mind that if you reduce the window width, you need to reduce the amplitude as well. So have a little play with that and see how you get on.